All right, let's begin our last lesson, 3.5, and solving problems involving vectors. We've been solving problems in 3.3 and 3.4 as well, adding and subtracting vectors, and we're going to continue to do so here. We know, just to recap before we get started, that when two or more forces act on an object, you can use vector addition or subtraction to find the magnitude of the resultant force. The direction of a resultant can be found using trig. So we've definitely learned that by now, and we can use, if a 90-degree angle triangle is made, we can use our primary trig ratios. Otherwise, we usually go to cosine law and sine law. Okay, now it can be expressed, the angle can be expressed relative to one of the given vectors, okay, or as a quadrant bearing. But I'm going to be looking to do this as a quadrant bearing in all of my questions. All right, so I'm going to be challenging you to find the quadrant bearing and not just the angle relative to another vector. Okay, so just to recap, adding two vectors. Okay, so here, let's say we have vector u, and here we have vector v. Just to recap how to add them, you can add them head to tail. Okay, where the resultant goes from your starting point to your finish point. So that is our resultant. Okay, there's u, there's v. Now, to express the angle here, you would have to find this angle, and to express it as a quadrant bearing, you would also have to know this angle here, because remember, a quadrant bearing is always measured from the north. Okay, so you would you'd have to use our trigonometry to find this, and then some sort of angle theory should provide you with this angle if it's not already given in the question. If we're subtracting these two vectors, what you do is you take your first vector and draw it as is, but your second vector you draw in the opposite direction, head to tail. So in the opposite direction means that it will go this way. Okay, so if I were to draw this head to tail here, it would do something along the lines of this, in this direction. And the resultant for that would be from the starting point to our finish point here. Okay? And once again, the angle, you'd have to find the quadrant bearing. Depending on where you are on your diagram, you can figure that out. Okay, so let's begin. Let's start with a simple question. Okay, Mary is walking to the library, which is 3 kilometers east and 2 kilometers north of her current position. Determine the magnitude of the resultant displacement to the nearest kilometer. So let's start by just finding the magnitude. It looks like the second question will be finding the quadrant bearing. So 3 kilometers east, well, that's just going to be a straight line going towards the east direction. Okay, 2 kilometers north, so I'm going to draw a line that's slightly smaller, and I'm going to draw these head to tail, right? Okay, there's 2 kilometers north. And the resultant this way, from the starting point to the end point. Okay, so this is going to be our resultant, our so we need to find the hypotenuse, essentially. This is a right angle triangle since we went straight from east to north, right? So it's a right angle triangle. How are we going to find our R here, our resultant? Well, I know that in a right angle triangle, I can use Pythagorean Theorem to find an unknown side when I know two of them. I'm going to use proper variables there, R, and I can use X and Y. Since this is going in the X direction, this is going in the Y direction. I mean, sure, why not? You could use u and v there as well. It doesn't matter. Okay. So we have 3 squared plus 2 squared, okay, is 9 plus 4, so 13. We're now taking the square root of 13. Now remember, this could really represent a positive or a negative, but our resultant, our vectors are always going to be positive. We're taking the absolute value here. So take the square root of 13 to the nearest kilometer. It's 3.6, but it asks us to do nearest kilometer. So we have a resultant magnitude of 4 kilometers. Now for the quadrant bearing, let's look at our diagram. If I find this angle, and I'll just put an imaginary axis here, okay? To find the quadrant bearing, essentially, I am looking for this angle here, right there. So from the north line towards the east. So even though I can solve for this side, how am I going to find this side here, this angle? Well, the two angles in there are complementary. They add to 90. So if I do 90 minus theta, I should get my quadrant bearing angle there. All right, so let's label this triangle. So we are going to be using either sine, cos, or tan. Okay. And if our angle of reference is here, that makes our opposite side here, our adjacent side here, and our hypotenuse there. Circle what's given, circle what you need to find. And what you find is that you circled O and A. So we're going to use the tan ratio. Okay, so 2 over 3, and then take the tan inverse of 2 over 3. And to the nearest degree, you get 34 degrees. Now, quick question. Why didn't I use my answer from the hypotenuse here, right? Because I could have used my hypotenuse. Technically, I found that it was 4. But I didn't use it because at the end of the day, I rounded it. It was really 3.6. And I don't know if that's, I'm using a pretty inaccurate number if I use 4. So I stuck with the numbers that were given to me, 2 and 3. Okay? So there you have it. You have theta equals 34. But my quadrant bearing... Okay, my quadrant bearing, like I said earlier from my diagram, if this is 34, then my quadrant bearing would be 90 minus 34. Okay, which is 56 degrees. So therefore, we're at north 56 degrees towards the east. Okay, there's your final answer for the direction. Let's move on. Okay, so we now have Kristen and Mackenzie are playing in a soccer game. Kristen kicks the ball 30 meters downfield, parallel to the sideline, and then Mackenzie kicks the ball 20 meters farther at an angle 38 degrees to the sideline. Determine the magnitude and direction of the resultant displacement of the soccer ball. Okay, so we have 30 meters down the field parallel to the sideline. So let's assume the sideline runs north and south. Okay. So this is our 30 meters. Then Mackenzie kicks the ball 20 meters farther at an angle 38 degrees to the sideline. So remember, the sideline's parallel to this line. And if we're 38 degrees to the sideline, then the kick must have gone somewhere in the direction like so. Now, it only went 20 meters, so it's slightly smaller than my other line, my other vector. Okay, this here is 38. And I know that it was kicked 20 meters down that way. Okay, so I did that because I knew that the kick was parallel to the sideline. All right, so it's north and south. Now my resultant is going to go from the starting point to the end point. Okay, now I didn't really do a good job there, but that's where it's going to go. So this actually works out nice. We have to find the magnitude and direction of the resultant. Because my kick was going north, if I find this angle, that's actually my quadrant angle, my quadrant bearing, okay? Because it's from the north. We assume that because I drew my field going north and south, finding that angle in there, I don't have to do any extra work to find a quadrant bearing, okay? I can simply find that angle in here, and that will be it. All right, so now I have a 30, 20, and a 38. I need to find this magnitude. Okay, well, if this is 38 here, then this angle in here must be 180 minus 38. Right? Those are supplementary angles that add up to 180. So we get 142 in there. So now I have a side angle side inside of my triangle. I can use the cosine law to find R. Okay, so R squared is equal to, let's call this U, let's call this V, doesn't matter what you call it. And write out your formula. Okay, and we'll call this angle R. We can call it theta. Maybe we'll just call it theta. Okay, sub everything in, and let's figure this out here. Sorry about that. I'm not sure why this would be called theta in here, not this. We're going to find that later. Okay, sorry. So cos of 142. I expect that to be negative, being in quadrant 2, that 142 degree angle. Okay, so 30 squared, 900, plus 20 squared, 400, 1300, minus, bring down your minus sign, 1200 times cos 142. Okay, so this is a negative number, like I said. And you want to get maybe about 4 decimal places there to improve your accuracy. Okay. Then we're going to end up taking the square roots here. So we're going to do 1300 plus 945.6129. Okay, because that will turn into a plus, the double negative there. We're going to square root that, right? We're going to bring the square to the other side and square root. And so our resultant then is the square root of our answer, which is a magnitude of 47.4, and let's call it 47 meters. Now the direction, like I said, if we just find this angle in here, that will also be our quadrant bearing because our initial vector was going towards the north, right? And the quadrant bearing is measured from the north. So I'll make some space right there. Okay, so let's go with, we're going to use the sine law. All right, so I'm going to call this capital V. Okay, I'll call this over here capital U. We'll call this capital R. Okay, so we're going to find an angle. So we're going to go the sine of capital V, that's what we're solving for, over vector B is equal to the sine of capital U. Oh, I'm sorry. We're going to have to use R there. The sine of capital R, because now we know what angle R is as well as the vector R. Okay? So sine V over the vector of 20 is equal to sine of 142 over the vector of 47. Cross multiply. Okay, divide out the 47 and take the sine inverse of it. So you end up with the sine inverse of 20 times sine 42, 142, divided by 47. Okay, throw that all into your calculator. So take the second function, sine, use double brackets here. Final answer is 15.2 degrees, but let's call it 15 degrees. So therefore, our vector is 47 meters and then north 15 degrees towards the east, right? Because we're going towards the east. If this is our north line, we are going towards the east here. Okay, there's your final answer for your magnitude and direction. All right, let's do our last problem here. So a boat travels 3 kilometers north 40 east and then turns and travels 4 kilometers north 15 west. Okay, so if this is my initial axes and I draw something 3 kilometers north 40 east. So north 40 east will be something about here. Then we're doing 4 kilometers north 15 west. So from this point, we're going north 15 west. That's our north line. North 15 west, and it's 4 kilometers. It's longer than the vector I just drew. Oh. Okay. Our resultant is going to go from our starting point. Okay, it's in a different color there, and actually that kind of stands out better. I kind of like that, even though it accidentally changed colors. There it is. There's our resultant. Okay, let's call this U. Let's call this V. Okay, so we need to find the resultant displacement, which means displacement is a vector, so we need magnitude and direction. So if I can find, well, I know that this is 3 kilometers, and I know that this is 4 kilometers. Do I know this angle here? Well, if this whole thing from here to here is 40, the whole thing, from the north line to that vector U, then this angle in here with the north line is 15 degrees. Okay? We're going to need some angle theories here. I clearly need to know this entire angle. Okay? I need to know that entire angle. Can I find that? Okay, so let's see. What can we do here? Well, if this right here, and I'll use a highlighter, I see a Z pattern there. So I know at least that this angle in here must be 40. Not that I necessarily need that right now, but let's see if that helps me solve anything else. Okay, so if I know that that's 40, I see another Z pattern right here. Okay? Well, that means I might know this angle right in there, which might be helpful as well. What is this angle here? 90 minus 40, which is 50 degrees, which means that this in here is 50 degrees. Okay, this is getting pretty interesting. Now, I know this angle in here, I know this angle is 40, and I know that this angle here is 15. All I need to know is this part, add it to 50, and I'll have my angle inside that triangle. And can I find that unknown angle right in here? Okay, this angle right there. I can. These four angles, 15, 50, 40, and then this, must add up to 180. They're all supplementary angles. So let's call it theta is equal to 180 minus 40 minus 50 minus 15. Okay, so what is that? 75 degrees. Therefore, let's call it angle R. That angle inside the triangle. I know this is getting pretty sloppy. I'm just going to draw a rough version up here just to make it more clear. Okay, this angle in here now is 75 plus 50. 125. That's your 4, that's your 3. You can now find the resultant. Okay, we have a contained angle, 4 angle, and then another side length. So, write out your cosine law. Okay, sub all your values in. And solve.